Okay, let's practice converting to decimal from other number systems. The technique is the same depending on the same for each number system. Effectively, you have a set of digits for whatever number you're in and a base. So let's start with base 2, which means I write the base out underneath each column. And then I write the power that the base goes for that column. So the first column is always the 0, and then the 1, then the 2, then the 3, then the 4. So we can then do the math. So 2 to the 0th power is 1, 2 to the first power is 2, 2 to the second power is 4, 8, and 16. And you'll notice that each of these is the previous column multiplied by the base. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and it will continue upward from there. So just remember that these columns now correspond to these powers of the base. So now it's just a multiplication and addition problem. So if I have in binary, I'm allowed to have the symbols 0 or 1 in my number. So if, for example, I had the number 1011, I now think of that and I can transfer that over into my grid here, and I could go 1101, and now I multiply downward. So I take 1 times 1, and that gives me a number of 1. I take 1 times 2, and I have 2, and I put a plus in between those. And I do plus 0 times 4, which is 0, plus 1 times 8, which is 8, plus, in this case, I showed the 16. You can think of that leading number as a leading 0, so 0 times 16 would be 0. I add across, so now I add this way, and I get 8 plus 2 is 10, plus 1 is 11. That's the number 11, the decimal number 11. So this is equal to, so a 1011 binary is equal to 11 decimal. Okay, so let's practice another one. Let's try 10101. Okay, so that would be equivalent to, again, I can think of it as 2 to the 0th power, which is 1, 2 to the second or first power is 2, 2 to the third power is 4, 2 to the fourth power is 8, and 2 to the, I'm sorry, I said 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. So there are my columns. So now I multiply downward. 1 times 1 is 1, 0 times 2 is 0, plus sign in between. 1 times 4 is 4, 0 times 8 is 0, and 1 times 16 is 16. Then I add across. This gives me 16 plus 4 is 21. So this binary number is equivalent to 21 decimal. Okay, so we don't have to convert just from base 2. Let's try something a little bit more complicated here. Let's try base 8 octal. So again, I write out some digits. Okay, I'm going to have my base, which is 8, to the 0th power. And then I have 8 to the first power, 8 to the second power, and 8 to the third power. So 8 to the 0th power is 1, 8 to the first power is 8, 8 squared is 64, and 64 times 8 is 512. So these are my places, the 1's place, the 8's place, the 64's place, and the 512's place. So that means I could have an octal number. And remember, octal's base 8. So the symbols I'm allowed to use are 0, 1, 2, 3, 4, 5, 6, 7, 8. Whoops. There, I just made a mistake. I'm not allowed to go to 8. That would be a ninth symbol. So I have to stop at 7. Okay, so that means I could represent a number like 0, 1, 6. 0, 1, 6. And this is in octal. So how do I convert it into decimal? Well, I take those numbers and I put it into my grid here. 0, 1, 6. Now I multiply downward. 6 times 1 is 6. 1 times 8 is 8. I put my plus sign in there. 0 times 64 is 0. I add across. You notice the technique is exactly the same. And this now gives me 14. So this would be 14 decimal. Let's try another one. Let's try 374. 374 octal. Okay, so again, I am going to write in my numbers here. So the first place is the ones place, the second place is the eighths place, and the third place is the 64th place. So I'm going to take 4 times 1, multiplying downward, 4. 7 times 8 is 56 plus, and 3 times 64 is what, 192. Hopefully I did that math right in my head. I add across, so I get 192 plus 56 plus 4, which would give me 252. So this is the same as 252 decimal. Okay, let's try one more. We're going to go base 16, which we call hexadecimal or shorthand for hex. The allowed symbols are, there's 16 of them. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we need another symbol that represents 10 because we're allowed to have the digit 10, but we can't represent it with a 1, 0 because that would be the same as in decimal. So what we do is we begin to use letters. So A, B, C, D, E, F. So those are 16 items. 9, 10, 11, 12, 13, 14, 15. Again, biggest number I can represent is 15. So if you're in the hexadecimal system and you see the symbol C, you need to think of that as a 10, 11, 12. So this is the same as us thinking of a 12. This is the same as us thinking of the digit 15. It's a little weird when we start to go above the digits allowed in base 10. So let's take a 3-digit hexadecimal number. Again, I write in my base 16, 16, 16. I write it to the 0 power, the 1 power, and the 2 power. So this is the ones place. This is the 16s place. And 16 squared is 256. So this would be the 256th place. So we can, again, start with a number like, how about 0A 2. So the hex number 0A2, what does that equal in decimal? Same technique, write out my digits in my grid here. So this would be a 0A2. So I multiply down, 2 times 1 is 2. A times 16. Now, what does A times 16 mean? Well, you got to remember that A in decimal means 10. So this is really 10 times 16. So 10 times 16 would be 160. 0 times 256 is 0, so I add across, and I am left with 162. So A2 is the same as decimal 162. Let's do one more. Let's do something like F 3D. So again, the first column is the ones column, the second column is the 16s column, and the third column is the 256 column. So I would have D, which in my number, so I might as well just write these out here so it's a little easier to see. Okay, so D is 13. So this would be 13 ones plus 3 16s plus F, which is 15, 15 256s. Going to grab my calculator here real quick. So 15 times 256 plus 3 times 16 plus 13 equals 3,901 decimal. Oops. Hex decimal. You'll see how compact that is. It's starting to get a 4-digit number, now is only 3, and we can get pretty big numbers represented with a few hexadecimal digits.